appreciate the muted color scheme. I was going through the what's new in Keynote and I saw this, it's animated. Do you see it's animating? The gradient is animated. I couldn't not use this. It's hilarious to me. It's also color coordinated with my hairstyle and shirt. That's not an accident. And the demos you're going to see later, well, some of them I ruined the CSS in the last minute. Whatever. So that's cool. What are we going to talk about today, though? Not about color schemes. So a while ago, this showed up on Twitter. And yeah, obviously, this was meant as a joke. However, the joke never stopped me from taking something seriously. And by the time this scrolled through my feed, I actually had been working on this talk for quite a while already. And now I had the perfect cover image for the fullest stack. It's like we're going from all the way down, really, really close to the metal, to very, very, very high up in the browser or in a native UI or wherever. The alternative title for this talk is Nerd Snipe All the Audience. So I'm really hoping to get you excited about what I'm going to show you, what I'm going to talk about, and maybe get some collaborations or idea interchange going. I also noticed when I was going through my slides last night, there's a decent amount of overlap between this talk and quite a few others, and this is great. This is really, really cool. Like, I'm not worried about that. Okay, we're going to hear the same talk 5 times over. I think everyone, or I hope for me, I'm sure for everyone else, brings a unique angle to their talk. And so, yeah, we've got the keynote where Steve said Rust not only on systems on the low level, but also on high level in the web stack. This is exactly what I'm going to talk about. We're going to hear from others about cross-platform UIs. Also in this talk, fleet management, kind of touching on that. Full stack game dev. Well, not game development, but yeah, you're going to see some patterns. And that's going to be interesting. So yeah, shamelessly soliciting contributors. All I'm going to talk about today is open source. Not everything is already published, but it will be very soon, TM. And so I hope that together we can make the Rust ecosystem go even more brr, or sir, but I think that's construction. Right, so who am I? I'm a freelance hired gun, and I've been through a lot when it comes to software development. I've done web front-end, web back-end development in Ruby, Python, TypeScript, JavaScript, Java, yada, yada. I have done web development in Perl. Has anyone else besides me? Wow, I'm not alone. I won't go back, but yeah. So whatever, mobile apps and Objective-C, Swift, Java, native apps, C, reverse engineering, yada, 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 yada. Being very much a jack of all trades person, but no matter how much experience I got and no matter how many test-driven design ideas I threw at a project, I never felt quite at ease. Because, like, how do I know my software is actually doing what I want it to do? And yeah, we all know the story. Rust makes me, and probably also a lot of other people, sleep at night. Haskell always looked exciting, but I never managed to get off the ground with it. Not because monads. Monads are cool. But formal methods are too academic. So Rust, really a sweet spot for me. But we're also not going to hear about that today either, because you already probably heard a lot of people talk about fantastic memory safety, fancy pants type system in Rust. Yes, we know, it's great. But not the title of this talk. So yeah, all my socials on this slide. The first one is probably the best hub to stay in touch with me. Working on some blog posts. It's really empty right now, but all the contact information is there as well. So you really just need to write down the first one. So enough about me. Let's actually get to the subject matter at hand again. But yeah, before we continue, let's hear a few words from today's sponsor. And it's actually, no, this is not our sponsor for today. This talk is not sponsored, but it's kind of a collaboration. So a huge thanks and shout out to James Munz, who is in the audience somewhere. Yes, hi James. Without James, this talk either wouldn't have happened or would have taken a very different shape. So he donated some awesome hardware for me to play with, so you don't have to look at my shoddy soldering jobs. And also, if you remember the alternative title for this talk, what I'm about to show you is, a lot of it is actually the result of mutual nerd sniping between James and myself. So things went like, James said, you know, I really need a UI for this kind of project. And I was like, yeah, I do a lot of UIs. Maybe I can help you out. And then I was like, yeah, okay, now we have this, but I need help with this and that. And James was like, oh yeah, I have this, but I never had a use case for it. And you brought me one. And so yeah, things just spun out of control massively. Yeah, so James is not a sponsor, but you should still business with him. He will never oversell you a VPN, as far as I know. Right, so now we know about James and myself, but who are you? I want to get to know my audience a little because some talks I've seen, not only about Rust, but there seems to be a pattern where the speaker is a bit confused about the target audience and their skill or familiarity level. So you would have some really, really advanced Rust topic where I'm like, okay, I really need to take time to digest this. But in the same talk, the speaker would spend then 10 minutes explaining how clone and boxing works. And it's like, yeah, I mean, it's good to know, but there seems to be a discrepancy with the rest of the subject matter. So I'm going to shoot a few questions in your directions, just show of hands mostly. And based on your responses, I'll try and dynamically adapt and expand upon the topics that I think make most sense to you, the audience. Did someone say dynamic? I would play an ominous foreshadowing noise if I had one, but I don't. So let's get to know you a little. Quick show of hands, who here has done Rust for over 6 months in one way or another? Okay, that's the vast majority. Who has seen James Munz's talk at Rust NL this year? Okay, that's not so many people, that's not a problem, but good to know. Who has done embedded Rust development in particular? Fantastic, I'm in the right room. Who has used Postcard? Okay, fantastic, that's actually less than I expected. Now, who has used Postcard RPC? We're not alone, James, we're not alone. Next grade, 2 more. Who has used dformat, or at least heard of it? Okay, it's about a third, like Postcard as well. And last grade, who has heard of Dioxys, or used it? That's great. This is actually more or less what I gauged in terms of what I'm going to focus on anyway, so I don't have to rework the slides in my head too much. Great, great, great. Quick table of contents. What is going on in the rest of this talk? This talk is pretty packed. If you have a quick question, feel free to raise your hand and or just shout it out. I don't care either way. Otherwise, it's probably best to save it for the Q&A or just meet me after the talk. I have a lot more demos than I'll be able to show on stage here today. So if you just want to see some more mad science, I can show you some stuff. Yeah, so I'm going to talk about what actually makes Rust, I think, the best language for developing heterogeneous, complex applications or projects, and what role a browser or a web view has to do with that. I'm going to show you an example, hopefully two. We're going to look behind the curtains for that, and then, yeah, some outlook and maybe hopefully nerd snipe you a little and take a look at more demos, and we will conclude with a quick Q&A. So, there are so many words that one could vaguely use to describe the general ideas floating around in my head. So you might have a stack for developing an application, or it might run on a platform or on several platforms, on a target, on several targets that might communicate with each other. So maybe that's actually a microservice or a set of microservices. You know, typically HTTP, but why does it have to? Or do you want to coordinate between those elements? Do you have some kind of broker that negotiates this communication? And what is a runtime? Do you want a runtime? Do you have a runtime? So yeah, what does this all mean? First and foremost, Rust excels at cross-compilation. You can download it and build for essentially whatever you want on your machine without going fancy by spinning up a virtual machine, so your target architecture is actually the same architecture as the compiler and everything just gets annoying. The one caveat is, of course, the linker, but even that is not usually hard to solve. And so why is cross-compilation important? When you build complex applications with many moving parts and many different, vastly different components, you are probably not going to target just one architecture or one kind of system. So let's say some part of your project runs in the cloud or someone else's computer or in your own data center. You have some devices in the field that have sensors or are just a panel in a lab and have some, what's the word? Peripherals that you want to control or get data out, data in, all this stuff. Yeah, we've already mentioned fleet management, sensors in the lab, and you want to control all this somehow, so you need some kind of user interface. And yeah, a bit more about Rust. It's, as we all know, a modern language with really cool types that kind of, sort of, most of the time just work everywhere. So you can just take your project and usually without any kind of changes, build it, or parts of it, big parts of it, for every element in your complex application. Some exceptions, of course. You don't always have the kind of floating point you want on an embedded device. You don't always have a heap. But this can be worked around in several ways. Quick shout out to the managed crate. It's pretty useful for when a heap is optional, but you want to have like some data definition that you use either on an embedded device or on a desktop or whatever. So yeah, with Rust, I didn't come up with this, but it's a really, really good fit, this sentence. You write once and you don't run. It's not Java, but you can compile anywhere or to anything, any location. And so, yeah, Java, nothing against Java, but kind of like we got this universal runtime by accident. And so Sun had the idea to build this Java virtual machine that you would install on your computer and use it as a host for rich applications. But what happened instead, the client-side JVM fell a bit by the wayside, especially inside a web browser, but the web browser itself became this universal runtime by accident. And modern browsers are really, really capable. They're not just about rendering HTML and doing a bit of animation with JavaScript. They're actually very rich in terms of APIs they have to offer. And I'm going to show you some of them. So very roughly speaking, by runtime, I mean that is some kind of vaguely defined thing that provides some services. Let's say, for example, you can do 2D graphics, 3D graphics, sound output, input, all this kind of stuff. And so, especially with a browser, we're standing on the shoulders of giants. And one thing that I want to hammer home is don't build your own runtime, then you can just reuse an existing one. In general, don't reinvent the wheel. cycling back to the concept of a complex heterogeneous application. There needs to be some way for all of these parts to communicate with each other. And for that, you need, well, some kind of connection, of course, but also a way of talking data. And so this is where Postcard comes in. You could use JSON. Who's familiar with JSON? All right, many more people than with Postcard. So Postcard is like JSON, it's an encoding or decoding scheme, but it's binary and it's really, really efficient. And this is important, especially when embedded devices or resource-constrained devices are part of the mix of what you're working with. So yeah, JSON, it works, but sometimes it's a bit wasteful. It does work on embedded Rust. You can totally make it work. But sometimes, you've got an embedded device because it's got to go fast. So yeah, just very quick tour of Postcard. Like I said, it's a fast, space-efficient, and embedded-friendly data format. Mostly Rust only. I think there's a TypeScript implementation or something. James, do you know about that? Okay, whatever. So this sounds like a bit of a problem. You've got a big complex application and your team is like, yeah, but we want to work in Java or we want to work in Go and blah, 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 whatever. It's like, yeah, okay, cool. And in this scenario, you're probably better off using JSON as a communication layer. However, I'm here to convince you to write just really everything in Rust, the entire damn project. That's the point of this talk. However, if you can't make this work, there are valid reasons for using legacy programming languages. And in that case, the good news is with 30, you can just decode, let's say, from Postcard and encode to JSON and the other way around. So you just have one communications boundary and use that to translate from data format A to data format B. Of course, it's always lossy. You can't 100% translate between different language concepts. So I would say avoid it whenever you can, but it's there if you need it to. So this is the clickbaity core idea slide of the talk, how to write complex applications in just one slide. You start by defining one single source of truth. You can call this data model or interface client definition or whatever. The important point is it's not just data, what you would define. It can also be code. Sometimes it might be required to feature gate this based on the availability of the standard Rust environment, of course. And when you have that, you just compile it to wherever you need it. Like in your UI, you don't need maybe the driver for the LEDs on there, but you can simulate the LEDs. We also had that in the keynote, and it's actually also something you can do, which is really cool because you can still use then the same code that works with the real LEDs or the simulated ones. Totally easy. And never special case or convert from A to B unless you have a really good reason. In most cases, you can really just take your Rust code, compile it to wherever, and you shouldn't think, oh no, I'm on a different target, I'm embedded, this only has a few kilobytes of RAM, I sure need to if def or config gate it. Don't. Don't. Then some kind of data that gets sent from A to B, you might want to put it at rest, store it somewhere, either straight encoded by 30 or in a database. Then that makes more sense. That's also fine. And actually, some databases, we're going to hopefully, if I have time for that, see one are 30 compatible, so to say. So you don't need to translate to SQL back and forth. And once you've done all that, you just add a UI or a GUI. I put the G in parentheses because the concept I'm going to show you can also give you a terminal UI. Either way, please don't forget about accessibility. My demos don't have it because I don't need accessibility, but please, if you write user-facing applications, remember people have access needs, and we are here today, fortunately, in a situation where you don't need to cut corners in that department. The support is there. Please read about it and make use of it. However, on the other hand, like we heard in the keynote, yes, admittedly, UIs in Rust are still young and younger than established other platforms, and sometimes it shows really hard. I think you can make it work most of the time, and also the kind of application that I'm talking about here, we're not going to write the next Microsoft Word. We're not going to write a hugely complex client-side application with all the bells and whistles. We're here mostly for something I would call control surfaces. So you get some data in, data out, visualize it, control it, see your parameters, store your data, retrieve it, that kind of stuff. CRUD in terms of web development. And this is totally, absolutely 100% doable with Rust without cutting back in any sense. So yeah, consider using browsers or web views for your next UI in Rust. And with that said, it's demo time. So you bought some board on AliExpress or got one from James. That's cool. So you might have designed one yourself, or James did. Now what? Like, okay, it's connected, great. I can turn this. Nothing happens. So we want to speak to this guy somehow, right? And especially we want to play around with it. Like, you can probably not see this. I'm going to try and get a camera feed going for the demo. But there are lots of tiny LEDs on it, and we want to see how they look in certain colors. And of course, every time I'm going to change the color, I could write new firmware. But this just takes a lot of time. You need to build it, and then erase the flash, write the new firmware, run it. It's just, I'm too impatient for this. I have friggin' ADHD. Ain't nobody got time for that. I will say, yes?
With descriptive audio descriptions.
Fantastic.
About the camera. Speaking of accessibility.
Talk to this person about accessibility. Much more knowledgeable than I am. I just know the buzzwords. Okay. I'm going to skip one thing because we are on a tight schedule. So it's demo time.
Right now, the LED is red.
Sorry? You were saying?
The LED is red.
Oh,
there's also some yellow.
These guys. Okay, so this is we're getting somewhere. We're getting somewhere, but this is the wrong camera. No, actually, it's the right camera. Now let me get this to the other screen. That's even better. That's even better. Okay, I'm going to try and wing it with the available space somehow. Make this smaller. But it's better than me holding up a 5-centimeter large board for you in the back.
But that's what I'm here to do, is tell them what color it is.
Sorry?
I'm here to tell them what color it is, so you don't have to get the camera.
You can, but actually I'm going to do this. So apparently we are connected. This is great. And so let me hold this in front of the camera. So let's say I want to change the color on this board. Now let's pray to the demo gods. Is something happening? Yes, fantastic. You see this LED has turned red. This guy here. This one here. No, this one here. This one. All right, now I'm going to change the color here in the slider. And oh my God, it updates in real time. How cool is that? Right? And I can also change the index of the LEDs. So I can make them all turn green or whatever. So yeah, this is one thing you can do with this interface. The other thing is this board also has an accelerometer. So I can select the precision, the g-force we want to see, and also the update interval. Let's make things go blur because we're Rust, and update every 40 milliseconds. And let's pray to the demo gods once more and start the accelerometer. And yes, here we are. I can shake this guy around, and we are seeing live updates from the data. And this is so much more, this gives you much more insight. You can look at this log, right? But what does this tell you? It doesn't really make it easy to interpret. But when you see the live graph updating depending on the position of the accelerometer, I think that's much more useful.
Ooh.
It worked! The demo worked! All right, thank you, demo gods. This was the first demo. Oh my God, 5 minutes left. I gotta stop. I gotta talk a lot faster if we want to get somewhere. Yes, fantastic. All right, so how does this all work? I mentioned the Dioxys crate. Essentially, you write essentially HTML, but in a Rust macro sort of way. It's very similar to React, if people have heard of that. And it's also got a really sophisticated state management system under its hood, so it only re-renders whatever elements actually change, and that makes it go really, really fast. You saw this running in a browser. You can also use Dioxys to develop native applications that are like Electron apps, but good. Who likes Electron? So it doesn't ship its own browser like Electron does. It uses the system web view. And so Dioxys apps, native apps, only take up a few kilobytes. And so yeah, the UI you saw is based on Dioxys, and the chart you saw is just Plotters RS rendering an image in a loop and updating fast enough to still have like 30 or something FPS, which is nice. Okay, I'm gonna skip the communication part a little because time is running out. What I wanna hammer home though is, right now, you see, this is connected over USB-C. This is also why I showed this in Chrome. There is a standard called WebUSB, and I'm using WebUSB to talk between this device and the browser, and sadly, Firefox does not support WebUSB. They are gonna change their stance on Web Serial, so if you use serial communication, you can use Firefox soon, hopefully. Also, I hear Servo, the browser, who has run Servo. More than I would have imagined. I hear Servo supports WebUSB. I couldn't make it work. But yeah, if you want to get nerd sniped into improving a browser, work on Servo. It really needs work. It's great, but it needs work. Okay, anyway, my real point is WebUSB or Web Serial is just one way of communicating with these guys. You can use Wi-Fi, MQTT, mesh networks, pigeons, whatever. The driver that makes this RPC communication work only needs slices. It's completely agnostic in terms of what runs the communication layer. Talk to James about communication stuff. There are interesting questions to answer, like who guarantees data delivery? Who guarantees fast performance, like the difference between UDP and TCP, all this stuff. Anyway, cutting things short. Okay, I'm going to skip this as well. Time is running out. Okay, just very briefly. The UI you saw was handwritten, but I also wrote a crate that can auto-generate the entire UI for you based on introspection, again, based on a postcard experimental feature that gives you type information about all the structures involved. So you can introspect and just zip, let your GUI be auto-generated. Just sprinkle a few hints on top. Yeah, so I'm going to skip this as well. And also, yeah, this is the dynamic type stuff part, which was actually much more pleasant to write than I would have imagined. This meme is legally old enough to drink, I apologize. At least in Germany, it's 18 years old. Anyway, this auto-generation stuff required a lot of dynamic stuff, but it wasn't as bad as it sometimes is when the alternative is writing a lot of macros, yada, yada. Things are getting there. We're getting better. Okay, no time for the second demo, which is sad, because I spent a lot of time working on it. Let's wrap things up. We're not quite there in some ways, like debugging WebAssembly, which is the target for Rust applications in the browser, can be a nightmare. Compile times can be bad, especially link times are surprisingly horrible. The orphan rule can really be annoying when you are writing something that's very much composed of different crates and different ideas, and complex applications tend to have this. If anybody has heard of aspect-oriented programming as a Java thing, they might have had the right idea. I'm not sure, but they might. There are also some bugs. Sometimes things just keep rebuilding. I suppose it's a cargo bug that's not quite harmonizing everything with environment variables, especially with Dioxys apps that can really hurt. We're talking about build times of several minutes. Not cool. Runtime performance also not always optimal, but often also surprisingly good. And yeah, with just like that, and 23 seconds left on the counter, and some kind of mad science stuff on the slides. I'm done. What are your questions?
Time for one question, but if not, the good news is that we have our lunch break coming up after the next talk, and Anatol will be available and no longer frantically putting together his slides, so we can always address that.
And code.
Or code. Any burning questions? No? Otherwise, thank you so much, Anatol, for sharing, and thank you to the demo gods for having it all work out for us today.
All right.